the first thing we did in section 3.1 was start talking about a radian measure and convert back and forth between the two. So that would be the first type of question that I would ask. Do you know how to convert between degrees and radians? And so what was the thing we multiplied by to convert? Pi over 180 or 180 over pi, depending on which way we were going. So here, I have degrees and I want radians. So that means I need my degrees to cancel out. So what would we multiply by? If you have degrees, right, that's when, to make the degrees cancel, they need to go on the bottom. So you'll have to multiply by pi over 180. Remember, if we had degrees in minutes, we did 12 plus 52 divided by 60 times pi over 180 degrees. And we've talked about the many different forms you can use when writing your answer. So you could write this as a decimal in terms of pi, so it's like 0.0715 pi, or you could put it as a fraction, 193 pi over 2700, or if you did include the pi as well, you get a 0.2246. Any of those three answers are okay. So there are lots of equivalent forms. You just have to give me one of those. Typically, I leave the pi in there, so I prefer like the first and second. A lot of times we're going to get nice answers like 3 pi over 4, those kinds of things, so we don't want to multiply out the pi there. But when you have degrees in minutes, it's very likely that your answer will be ugly, so that would be one where you might choose to multiply out your pi. What if I want to go the other way? So if I said I have radians and I want degrees, you just put the fraction. So in this, the pi's drop. The negative doesn't change anything. We just have negative 17 over 5 times 180. So we get a negative 612. But if I just write that, I'm going to count off. Why? Degrees. We are to that point. If you mean degrees, you have to put degrees. If I just say 10, is that degrees or radians? Radians. So any number without a unit is radians. If you want degrees, put a degree sign. Are we okay on conversions? The second thing, we did that circle in section 3.1, and we are actually going to revisit it starting tomorrow. But I could still ask you to evaluate some trig functions. So let's say I asked you to find the sine of 11 pi over 6. When we evaluate these things, we have to put quadrants and reference angles with that. Ideally, I would like for you to be comfortable enough with radians that you could do this from looking at our problem. And we know in quadrant 1 it's always pi over a number. In quadrant 2 the top is 1 less than the bottom. In quadrant 3 the top is 1 more. And in quadrant 4 it was double minus 1. So what quadrant would this be in? Reference angle. If you are in radians, you can just ignore the number on top, so it's just pi over 6. Pi over 6 is like what in degrees? Pi over 6 is the same as 30 degrees. In quadrant 4, is sign positive or negative? Negative. Then the sine of 30 degrees. So our hand trick, this one will never go away. We have to be able to evaluate these forever. So it's the square root of 1 over 2. So our answer is negative 1/2. Now, this problem looks different because I gave you radians to begin with. And yes, I want you to get to the point where you can deal with the radians, but if you were absolutely stuck, what could you do at the beginning? If you don't know what quadrant this is in, could you change it 2 degrees? Same thing we were doing on the previous problem. If you have radians and you want degrees, you would multiply by 180 over pi. And that gives you 330 degrees. And then do you know that 330 is in quadrant 4? And the reference angle there would be 30. So then it's just like a question that I would ask on the last test. We had things like those on the last page. So the only difference is how that initial number looks. And while, yes, I want you to get comfortable with that, if you're not yet, you could change it into degrees and work with that. So if I said secant of 5 pi over 4, what quadrant is 5 pi over 4 in? Reference angle. It's just pi over 4, which is what in degree form? But if you were stuck, you can multiply by 180 over pi here. So you have 5 times 180 divided by 4. And you get the secant of 225 degrees, which you can say is in quadrant 3 with a reference angle of 45. Same thing. Now we need to evaluate. Is secant positive or negative in quadrant 3? Negative. Secant of 45. So secant's a reciprocal of cosine. So the cosine of 45 degrees is radical 2 over 2. So secant would flip that. And you get negative radical 2. So these are like old questions. I'm just changing the initial way it's asked. For the last one here, if this were in degrees, if I gave you a negative degree measure, what would you do? If I said like negative 90 degrees, what would you do to that first? Add 360. If we're in radians, what's the same as 360 degrees? So you could add 2 pi to this to begin with. If you do that on your calculator, you just don't do the pi. So you do negative 5 over 6 plus 2 and do your math fraction. So that gives us 7 pi over 6. What quadrant is 7 pi over 6 in? Reference angle would just be pi over 6, which we know is like 30 degrees. In quadrant 3, is tangent positive or negative? Positive. The tangent of 30 degrees, that's radical 1 over radical 3, which gives us radical 3 over 3. But again, if you're not comfortable with those radians, you can always convert it to degrees and then work from there. Do we need more of those?
Yeah, so we have almost all in the class. I'm gonna just ask a question.
Yeah.
For things like this, how do you go from that to that?
So when you're in radians, the reference angle is good if you just get more than that. This is just pi over 6. Pi over 6.
Okay.
And we know if it's over 6, that's the same as 30 degrees. Over 4 is the same as 45, and over 3 is the same as 6.
Thank you.
Other questions? So that's all the stuff from section 3.1. Let's talk about 3.2, the homework we just turned in. This was a problem that a lot of people came in and asked me about, so I wanted to talk through one like this. All right. The minute, do you want me to let you write? Some of you are writing. No, it's fine. So we're talking about a clock. And it says the minute hand is 2.3 inches. So if you think about the minute hand, it's from the center out. What variable is that? So my R is 2.3 inches. We all know that as time goes on, this minute hand spins. So I want to know how far the tip of the minute hand spins. So it's spinning around the outside of the circle, so what variable is that? So we're trying to find S in 5 hours. Okay, we have two formulas. S equals R theta and A equals 1/2 squared theta. 1/2 R squared theta, sorry. I told you I'll give you those formulas. They're on the board right now. You just have to know what to use. Which of these formulas would be helpful here? Yeah, the S equals R theta. But I don't have theta. So that's where this 5 hours comes into play. We know that in 1 hour, the minute hand goes all the way around the clock. What's the angle if you go all the way around a circle? 360 degrees. But if we're going to use a formula, the angle has to be in radians. So 360 degrees is the same as 2 pi radians. So every hour it travels 2 pi. We're spinning for 5 hours, so you need to do 2 pi times 5, which gives me a total angle of 10 pi. So now we can just do the S equals R theta. 2.3 times 10 pi. So S is 23 pi. What kind of units would we put on this? Area.
No, just inches.
Yeah, area is square, but S will always have the same units as R. They're just a distance, so inches, centimeters, something like that. Is that all right? Let's look at another one. This is about as complicated of a problem as I can give you right now. An arc of length 4 centimeters is cut off by an angle of 60 degrees. Find the area of the sector formed. All right. An arc of length 4 centimeters. What is that? S. Arc length is S. That's distance on the outside of the circle. It's cut off by an angle of 60 degrees. An angle is what variable? I want to find the area, so I'm looking for A. So my area formula, A is 1/2 R squared theta. What's wrong with that?
There's no R.
We don't have R, so we can't use that formula. So we have to do some background work. We need to find out R so we can go to the other one. So this problem is going to require us to use both formulas. What do I need to do before I can use this formula? So 60 degrees, you might remember, is pi over 3, or you could multiply by pi over 180 and get that. So now we can do S equals R theta. So S is 4, we don't know R. Theta is pi over 3. So don't want to solve for r, we can multiply by 3. Divide by pi. So r is 12 over pi. I'm not done, because we have to find area. Are there any questions about how we got r? Okay. So then we can plug in a is 1/2 r, so 12 divided by pi, squared theta is pi over 3. So I'm going to put this all in my calculator. This would be a problem where I would probably just go ahead and plug in the pi's as well. And I'm going to get 7.639. What kind of units should this have? So this is the most complicated problem because A, you had to change your angle into radians, and B, you had to use both formulas to get there. Right. Questions?
When do you know I'm squared again?
Area is always squared. And it's just the units, not the number itself. Other questions? Think we're ready for this? I think you guys can do it. Please show all of your work, don't just write down the answer. The formulas are on the board. If for some reason somebody wants to do one of these tables like we had in the last test, when you get down to those questions, if you think you need one of those, just let me know.